In this video we'll discuss what are deployments. In the previous video we saw what are replica sets. Replica sets make it easy to create and manage replicated pods. So the pods which are created by the pod manifest can be replicated using the replica set. In an easy way you can think of replica set is a cookie cutter and a desired number of cookies into a single API object. So you can think of replica set as a cookie cutter where you have a specific specification for the cookie cutter. Example, let's say you have a cookie cutter of this star shape and you want this 3 number of star shaped cookies. So what does this do is you write the specification of the star shaped replica set and then apply it using the kubectl apply command. That is the replica set YAML. When you apply this, the replica set object will be created and it will see for the number of replicas you have put in the YAML file, from which the number of pods will be created. So when we define a replica set, we define a specification for the pods that we want to create. That is the cookie cutter, that is the star shaped cookie cutter, and the desired number of replicas. Additionally, we need to define a way to finding pods that the replica set should control. That actually is managing the replicated pods. So the managing of the replica pods is an example of reconciliation loop which we have discussed. So managing this star shape, let's say I want 3 replicas. So with this cookie cutter specification I create 3 replicas. Specification of the cookie cutter, I create 3 replicas, and this type of mechanism is called a reconciliation loop. Such loops are fundamental to most of the implementation of Kubernetes. Now coming to the deployments are used to manage the replica set. You can think of a deployment as an object on top of a replica set. Now if we consider the pods in the lower level, that is this, replica set are created on top of pods. That are replica set manage the number of pods you want in a cluster. That is, it does the mechanism for self-healing of the pods and scalability of the pods if you want to increase or decrease the number of pods, and it sees if the desired state of your cluster is equal to the current state of your cluster. If the desired state is not equal to the current state, then it creates the number of pods that are present in the desired state. Example, if a desired state has 3 pods and if in your current state you have only 2 pods, it sees that the 3 desired pods is not equal to the current 2 pods, so it will create one more pod using the replica set controller. So you can see in a way that replica set acts as a controller for the pods creation, and on top of replica set object you see the deployment, which handles the updates and rollback operation, which we will go through in this thing. So the deployment object exists to manage the release of new versions. So essentially deployments were created in Kubernetes to manage and the release of new version of their application. If you wanna update the version of your application, then it is much essential to use the deployment object. So using deployments, you can simply create a reliable rollout of new software versions without downtime or errors. The actual mechanism of the software rollout performed by a deployment is controlled by a deployment controller that runs in the Kubernetes cluster itself. This means you can let a deployment proceed unattended even if it still operates correctly and safely. This makes it easy to integrate the deployments with numerous CD tools and services. Now let's see how deployments actually work. And before seeing the hands-on of deployments, when Kubernetes was first expressed,